Okay, another design example. We have wooden joists are used to support a floor load of 6.95 kilopascal exclusive of its own weight. So, hindi pa kasama yung own weight niya, no? The joist will have an effective span of 4.25 meters and be placed 0.4 meters on centers. So 400 mm on centers. The timber is 80% stress grade. Apitong ulit yung ginamit na wood. Okay? So if the wood weighs 7.5 kilonewton per cubic meter and has an allowable deflection of 10 mm, design the most adequate cross section of the joist. Okay? So, yeah. So, to solve this, again, we need to conceptualize yung itsura nung natin, no? So, this is almost the same figure of our previous design example. So, we have a joist, okay? So, let's say, ito na lang yung joist natin, longitudinally, no? Then, assuming nakapatong siya sa girder, okay? And then, meron siyang floor load, okay? Not given yung floor load, pero in ano siya, no? So, parang um, uniformly distributed load siya. Okay? Na 6.95 kilopascal. So, in pressure siya. Okay? So, pag in-arrange natin yung mismong joist natin, yung cross-section natin, halimbawa ito, yung ating cross-section ng joist. Okay? Then yung floor system natin, halimbawa is ito. Okay. Then we have spacing down on joist natin is 0.4 on centers. So 400 mm. We have 4.25 na length. So ito po yun, yung length na yan. And then, ayan, may weight na siya na 7.5 kilonewton per cubic meter. And then meron tayong allowable deflection. Okay, so yan yung figure natin. Ngayon, itong floor load natin na 6.95, para matransfer siya dito sa length ng ating beam, ng ating joist, kailangan kunin natin yung tributary width natin, which is um, select natin yung isang portion, yung isang beam, and then kunin natin yung tributary, yung half-half dun sa left and right portion niya, no? So, pwedeng ito yung maging tributary width natin. So, ito yung magiging area na susuportahan niya nung beam na yon. And ang distance niya is, that is also equal to 400 mm. Okay? So, to look for the applied load dun sa ating mismong beam, so, yan. Ano yung meron dyan sa loading natin na yan? Yung loading natin na yan is magiging siyang yung WT natin, yung total. And anong consideration ng WT natin? Yan yung floor load natin plus yung self-weight nung mismong joist natin. But the problem is, wala tayong cross-section again. No? And again, for floor joist, no? Ang practice lagi is 50 mm yung kanyang width. Okay? So, yung width natin, again, is 2 inches. Then, unknown yung depth natin. Okay? We need to solve for the value of D. Ang meron tayo is si floor load. So, we can estimate D by using muna siguro yung value nung floor load natin. Kasi comparing yung value ng floor load with the value ng self-weight o yung mismong bigat ng nung timber na gagamitin natin, significantly larger yung value ng floor load, no? So kung ano man yung makuha nating assumption na D for floor load, um, tatry natin gamitin para dun sa kasama yung self-weight niya para ma-check natin kung kakayanin ba niya yung depth na gano'n. Depende dun sa loading niya. Okay? So first, may mga rule of thumb kasi pwedeng gamitin no? Na pwedeng consider. No? Sometimes ang self-weight of Joyce is around 5 to 10% of floor load. Okay? So, sabihin, pwede mong multiply ng 1.1% o kung 10% ang i-assume ko. Multiply ko ng 1.1 yung 6.95 kPa na weight and then para ma-consider mo na yung self-weight niya. Okay? So, let's try siguro parehas. Applying yung rule of thumb tapos applying yung hindi. Okay? So, let us first consider yung floor load natin. Okay? Consider first yung floor load. So, yung kung floor load lang, ang ating magiging weight ngayon will be equals dun sa 6.95 kPa yon. So, yun ay kilonewton per meter square. Then, para makuha yung uniform distributed load niya, again, kailangan lang natin multiply dun sa kanyang arbitrary width. That is 0.4 meters. Okay? So, 6.95 times 0.4, we have 2.78 kilonewton per meter. Okay? So, yan yung value ng ating um, weight kapag floor load lang. And then, let's try to get yung value ng D, no? So, wala pa pala tayong properties ng apitong, no? So, since that is apitong also, let me get yung property na nakuha dun sa table. So, this is the table. Okay? And then when we move dito, this is the apitong. And then ito yung kanyang corresponding values for bending, yung first column. Yung second column is for modulus of elasticity. And then yung last column is for shear. Okay? So let me get that values. Yung nilagay din natin dun sa previous example natin. So this one. So allow me to get this. Okay, then we will use this same property dito. Ayan, so yan yung ating property ng apitong. Okay, so let's check for bending. So we can use FB is equals dun sa allowable natin para makuha natin yung minimum dimension. So we can use 6m over BD squared. So this is equals to 6 times WL squared over 8 pa din, no? Kasi simply supported or uniformly distributed load na simply supported, BD squared. So FB natin from the property is 16.5. Okay? So 16.5 Newton per mm squared is equals to 6 times yung weight natin. So yung weight 1 yung gagamitin natin, which is yung according to floor load lang. So 2.78. So 2.78 kilonewton per meter, no, 1 kilonewton per meter equals din sa 1 newton per mm. Okay? So ito ay magiging newton per mm. Times yung length natin is 4.25. So 4,250 mm. Then we have to square. All over, yung B natin again is 50 mm. And then yung D natin is unknown. Okay? So, solving for D, ano makukuha natin? 6 times 2.78 times 4,250 squared all over 16.5 times 50. And then we have a value. Square root natin yung value. We have 604.31 mm. Okay? So, as you can see, ang laki nung width natin, no? So, let me check lang again the calculation. If correct, 2.78 times 4,250. So, okay. Ito, yung isa, no? Yung 2.78 is in kilonewton, no? Nilagay ko dito is in newton na. So, dapat naka-multiply pa to by 1,000. Okay? So, be very careful with that. So, times 1,000, ayan, and then square root of the answer. So, 6 times 2.78 times 1,000 times 4,250 squared all over 16.5 times, nawala yung 8, no? That may 8. 8 times 50. So, we have some value. Then, square root natin that value. What will be the value? Okay. So, let me check. Kilonewton per meter. Um, ah, as I've said, equal na siya sa Newton per mm. So we don't need to multiply by 1,000 anymore. Okay? And then we can calculate this. 6 times 2.78 times 4,250 squared. Over 8 times 50 times 16.5. Whatever is the answer, square root of that answer. So we have 213.66 mm. Okay? We can say it can be 225 mm as our D. Okay, so if we will use 225 as our D, we will be trying out 50 mm by 225 mm. Okay, so what will be the weight ng wood alone? That is equals dun sa unit weight natin, which is given on the problem, times yung area ng cross-section. So we have unit weight of wood is 7.5 kilonewton per cubic meter. So 7.5 kilonewton per cubic meter times 0.05 meters yung 50 mm, then 0.225 meters. Okay, so we have weight of wood is equivalent to, yeah, so 0.084375 kilonewton per meter. Okay? Or newton per mm. So pag gusto natin kunin yung actual value ng FB natin, that will be 6 times yung 2.78 natin kanina plus 0.084375, yan yung ating weight ng wood, times 4,250 squared all over 8 times 50 times 225 squared. So yung actual value ng flexure natin will be equals to squared all over 8 times 50 times 225 squared, equal siya sa 15.33 MPa, which is less than dun sa ating FB. So therefore, okay for flexure na tayo. Okay? So, ayun. So, yun yung ating unang cross-section. Okay? Next, for i-check natin kung halimbawa ang gagamitin natin is yung rule of thumb na halimbawa 10%. Okay? So, lagay natin dito. So, case 2, halimbawa yung ating weight total will be equals dun sa weight natin na 2.78 kilonewton per meter. Multiply natin ng 1.1. Okay? So, nag-assume tayo, assume 10% weight of wood. Okay? So, 2.78 times 1.1, that is equals to 3.058 kilonewton meter. So, magiging value ng FB natin, um, so equate natin siya doon sa FB para makuha natin yung value ng D squared natin. Okay? So, this is equals to 16.5 is equals to 6 times 3.058 multiplied by 4250 squared all over 8 times 50 times D squared. So, makukuha natin value of D is 6 times 3.058 4250 squared all over 8 times 50 times 16.5, then square root of that answer. Makukuha natin is 224.084. So, lampas na siya ng 200. So, say 225 mm. Okay? So, same assumption siya nito sa first one. So, pag check natin yung flexure, it will be okay with flexure din. Kasi it will be the same dimension ng D. Okay? So, you can assume 10% as your weight ng wood for verification. Since design naman to, hindi, wag mong ilimit yung mga ina-assume yung values, no? Okay? So, pwede nga halimbawa to, kung kahit increment lang siya by 25, pero kung wala naman sa market ng size na for 4.5, no? Hindi available dun sa hardware na malapit sa'yo. Halimbawa, available lang ay 5, edi gamitin mo is yung 5 or yung 6, no? Okay, so pwedeng 250 mm gamitin mo. So depende sa inyo as designer. Pero tayo, dito tayo sa minimum lang muna tayo, no? Para yung sa economical aspect, satisfy natin. Alright? So let's continue. Let's check for shear. Okay? Ang ating dimension is 50 mm again by 225 mm. Okay? Formula for shear is 3/2 V over BD. This is also equals to 3/2 WL over 2BD. Okay? So that will be 3/4. And kung ano yung W natin, so we can use either doon sa dalawa. So, gamitin na lang natin tong eksakto, no? Na value. Kasi base yan dun sa actual weight. So, 2.78 plus 0.0084. That is equals to 2.864. Okay? So, 2.864. Okay? Ang unit natin ngayon is Newton per mm times yung length natin na 4250 mm all over yung B natin na 50 mm then 225 mm. Okay? Cancel out yung mm doon. Matitira is Newton per mm squared or megapascal. Okay? So 0.75 times 2.864 times 4250 all over 50 times 225. We have a value of 0.81 MPa. And pag tinignan natin yung allowable shear natin, that is equals to 1.73. So, less than tayo do sa 1.73 sa allowable natin. Therefore, safe for shear. Okay, so okay na tayo kay shear. Next, deflection. Okay? According dun sa problem, in-state niya na ang ating allowable deflection is 10 mm. Okay? So, lagay na lang natin na allowable ay 10 mm. So pag kukunin natin yung maximum para dun sa problem, we have 5/384 times W L to the fourth over EI, wherein yung I natin is equals dun sa moment of inertia ng rectangle, that which is B D cube over 12. Okay? So we have 5/384 times W L to the fourth. Then yung E natin is nakuha dun sa table times B D cube. Then yung 12 pwede nyo nang i-multiply dun sa taas. Okay? So substitute natin yung mga values. 5/384 multiplied by W, which is 2.864 Newton per mm, times length na 4,250 mm to the fourth, times 12 all over the value of E based from our property is 7.31 gigapascal. So multiply natin ng 1,000 para maging megapascal. So this is 7.31 times 10 cube Newton per mm squared. So megapascal na yan. Times yung B natin, which is 50 mm. And then yung D natin na 225 mm cube. Okay? So let's calculate. 5 times 2.864 times 4,250 raised to 4 times 12 all over 384 times 7.31 times 10 to the 3 times 50 times 225 cube. Okay? We have a value of 35.068 mm, which is way, way, way greater than do sa 10 mm limit natin. Okay? Therefore, ano ibig sabihin? Magpe-fail, no? Fail in deflection. Nag-fail siya in deflection, anong gagawin natin? Gawin natin is resize natin yung section. Okay? Resize section. Okay? So, kung meron kayo nitong 225, no, using the same formula, hanapin niyo yung pwedeng value. Or baliktarin natin. Tulad yung ginawa natin sa flexure, no? Gawin natin yung ating deflection actual, equate natin dun sa allowable natin, which is 10 mm. Okay? So, 10 mm is equals to 5 times yung W natin is 2.864 times 4,250 to the fourth times yung 12 all over 384 times 7.31 times 10 cube 50, and then hindi natin alam yung depth, no? Na masasatisfy siya. Cube. Okay? So pag kinalculate natin yung D, that will be equal to equal siya sa 341.84 mm. Or say natin as 350 mm. Okay? So, tingnan natin, check natin yung actual. So, 5 times 2.864 times 4,250 times 12 all over 384 times 7.31 times 10 cube times 50 times 350. Okay? Pero before that, we need to adjust yung weight natin. Okay? Kasi nagbago yung depth natin, definitely yung weight ng wood natin magbabago, no? So try 50 mm by 350 mm. Okay? So yung weight ng wood will now be equals to yung area natin. So 7.5 kilonewton per cubic meter. So times 0.05 times 0.35. So this will be equals to 0.13125. Okay? And then, yung magiging total weight natin ngayon is from our previous one. So let us adjust it here. So yung W total natin will be equals dun sa original natin kanina na 2.78. Ito yon, no? So 2.78 plus 0.13125. So we have 2.911, okay, kilonewton per meter. So let's change this value, 2.911, okay, and then calculate natin yung magiging value ng ating actual deflection. Okay, that will be equal sa, okay, actual deflection now will be equals to 9.47, which is less than dun sa 10 mm natin. Therefore, safe for deflection. Okay? Ngayon, yung pag-check dun sa flexure, okay? Let's go back to sa flexure natin. Okay? Yung flexure formula natin is dependent dun sa value ng D natin. So, kapag mas malaki yung value niya, definitely yung value of FB will be lower. Okay? So, what will be the new value? So, FB will be 6 times 2.911, then 4,250 squared all over 8 times 50 times 350. Okay? Squared. So, 6 times 2.911, 4,250 squared, all over 8 times 50 times 350 squared. Okay? So that is 6.44 MPa. So less than siya ng allowable. So okay. FB natin is 3 halves o 3 fourths ng WLBD natin. So 3 fourths of 2.911 times yung length na 4,250 all over 50 times 350. Okay, so 0.75, 2.911, 4,250 over 50 times 350. We have 0.53 MPa, which is less than dun sa allowable shear natin. Therefore, okay. Okay? So, okay na tayo sa tatlong condition. Meron tayong deflection, sa flexure, sa shear. Ang kulang na lang natin is yung sa lateral stability. Okay? For lateral stability. Okay? So, kunin natin yung L over B natin. So, we have 4,250 all over. Yung B natin is 50. So, ang value nito is 85. No? Which is greater than 40. Which suggests na siya ay laterally unsupported. Provide bridging. No? Kailangan natin ng bridging. Okay? So, kung i-assume natin halves yung by midpoint, so pag by midpoint, magiging siyang L over 2B. So, that is 4,250 all over 2 times 50. So, ano mangyayari dito? This is 42.5, which is still greater than 40. So, hindi pwedeng by midpoint lang. By third points. No? So, L over 3B. So, 4,250 over 3 times 50. So 4,250 all over 3 times 50, which is 28.333, which is greater than 20 and less than 40. Therefore, partially supported na siya. Okay? Pero, we will need to check the value of F prime B. So, FB times 1 minus KL over B. Okay? Again, yung KL over B natin dito, yung L over B, pertains dun sa last calculated natin, yung gagawin natin bridging. So, FB natin from our property is 16.5. So, 16.5 times 1 minus 1 times 28.33 all over 90. So, according do sa table yan. F prime B is equals to 16.5 times 1 minus 28.33 over 90. We have 11.306 MPa. Okay? Then we need to check our FB. Our calculated FB is 6.44 MPa. Less than siya dun sa bagong FB prime natin. Therefore, safe for flexure and lateral stability. Okay? So, conclusion natin, therefore, use 50 mm by 350 mm apitong joist with bridging at third points. Okay? So, this will be our conclusion. Okay? So, what does it mean? So, halimbawa, again, ito yung itsura ng ating ISO ng ating joist. Okay? So, pwedeng lagyan natin siya ng bridging dito. Okay? Dito. Third points tayo, no? So, yung ika-third division, ibig sabihin ng third points. Okay, dito. Okay? So, ganyan yung mangyayari ng kanyang bridging. Okay? Alright? Thank you for listening.